Well, I'm finally completed my homemade do-it-yourself case feeder for my Dillon 650 press, and I'm pretty happy with the way this thing turned out. So some of the other videos, they were pretty. None of them have been that great because I'm not a video person, but I've done my best to kind of show the work in progress. Here it is actually mounted to the Dillon case feeder mounting pole, whatever it's called, and this is my take on the construction of design of a case feeder for the 650. This section here, as you saw in the earlier videos, made out of wood. These surfaces here and here is made out of plexiglass, and I just painted the back side of it the same color as the matching color of the Dillon, so that I kind of like that glossy surface there. Looks kind of nice. On off switch, this is the speed control for the motor. Here's the switch and the lever. I just loaded up this tube using the case feeder, and it's working just fine. This switch is actually the switch that Dillon uses. I ended up ordering one because I had just a devil of a time trying to find a switch that had the level of sensitivity that would have these light, cases only weigh some amount of grains. They're very lightweight, and all of the standard switches, lever switches, just were a little bit too stiff for these cases to actuate the filter. I mean the switch. So I just went to the Dillon website and ordered a switch, and call it a day. I probably ordered a total of 4 different switches from 4 different companies before I actually came to the conclusion that I just wasn't going to find one that was going to work. So I ended up going to Dillon and ordering their switch, and pretty happy with the result. This thing turned out pretty good. I have made the shell plates for 9mm and 40 Smith & Wesson. And I also made the shell plates for 223. The handgun round shell plate is in the press. Here is the shell plate for 223. I made this stuff out of polyethylene sheets, 1/4 inch thick. This is the same material that they make bread boards, cutting boards out of. And man, oh man, this is some great stuff. Real easy to work with, real easy to machine, very, very easy to cut. You can even whittle this stuff with a sharp knife or a utility blade, just like you were a bar of soap. You can just whittle this stuff and it'll just peel right off. If you need to make small little adjustments, like I ended up having to do with this thing. So it's perfect. In fact, I just drilled 4 holes here, drilled a center hole, and then just used a utility knife just to get those flat surfaces. There's a square spindle inside of the press. I don't know if you can see it from here, maybe. Yeah, there you go. There's a square spindle, 1 inch by 1 inch, and that is what drives the shell plate. The motor turns that spindle. The spindle turns the shell plate, and you're done. As you can see here, I have these actuators, not actuators, agitators added to the plate. Initially, they were just smooth surfaces, but the problem was with the smooth surface and nothing for the cases to bump up against to force them to turn and flip. The cases were just sort of like sliding down in a heap after they were sort of lifted slightly by the just friction of the surface here. So adding these agitators helps a lot, because when the cases are all sort of piled up at the bottom, these agitators are moving the cases, turning them, and by the result, it helps feed them into these slots here. And the same goes for the handgun shell plate. There's agitators there as well. So I know a lot of people talk about building these things out of this stuff, Lexan. I suppose you could do that, but this stuff doesn't machine nearly as well as this stuff does. Not only that, this stuff is incredibly resilient. You can take this thing, throw it across the street like a frisbee, and it'll be no worse for wear. Really good, great stuff. This should last for a very, very long time. At least I hope it does. The early videos, I talked about the motor that I was going to be using. Sorry about jumping around. And this is the motor that I was intending to use initially. And this is a motor from a rotisserie, a grill rotisserie. It's a slow RPM, but it's very high torque. The problem that I had here, the RPMs were just a little bit too fast. This thing turned out to be, to my surprise, 50 RPMs, 50 RPMs. Way, way too fast. So that's the reason why I added and installed this speed controller to slow down the revolution of this motor. The problem with that is reducing the speed means reducing the voltage. Reducing the voltage means reducing also the torque that this thing exerts. And at the low speeds that I needed, 4, 5, 6 RPMs at very top end of the speed spectrum, I just didn't have the torque. This motor did not generate the amount of torque with the reduced voltage that was going through it. So as a result, the weight of the brass, the motor just wasn't hefty enough at those low RPMs. Didn't have enough torque, rather, to push the brass around inside of the hopper. So what I ended up doing was going back online, and I ended up buying a motor from a microwave. I really didn't want to do that initially because I was fearful that I couldn't find one with enough torque. But lo and behold, after a lot of searching, I ended up finding an asynchronous motor that had plenty of torque. I don't know the formula for how torque is represented, but it's some kind of kilograms per, I don't know what it is. You engineering type guys probably know what that is. I'm just a tinkerer. I don't know anything about that. But I did find a motor that worked. I think maybe at some point I might take this thing apart and kind of show you what it looks like inside. But it's very simple. In fact, I'm not even using the speed controller because, as it would have it, you reduce the electrical current, you reduce the speed, you reduce the torque. You know, I need torque to move these brass around. Luckily, the motor that I have moves at like 5 RPM at its maximum speed, and that's plenty. That's more than enough to do what I needed to do. So anyway, I just wanted to show what my homemade case feeder looks like. I've showed it. I've shown other video with this thing. Sorry, actually moving the brass, you know, through the mechanism and into this section right here. Just before I made this video, I confirmed that it all worked, and you know, to fill this tube up. This is some Velcro and Velcro strip just to keep this tube in place, so the tube has a tendency to move out of place, and I didn't want that to happen. So, boy, this has been a work in progress. I am very, very happy with the result. So now I can actually start getting some rounds loaded up in earnest. I had managed to set this up and have it working with a Lee case feeder, which worked pretty good. But you know, you have to feed the thing often enough, and there was some hang-ups with the shells dropping into the this mechanism. So, you know, because of the Lee case feeder kind of like set in this position, and there was always an issue with alignment. So now that I'm using the Dillon tube, the Dillon whatever this thing is called, and everything is just dropping right into here, I'm golden. This thing is going to be rocking and rolling in no time at all. So there's my case feeder. We'll see some more video of this thing later. I'm glad the job is finally done. There are some real frustrating parts of this, but as you can see, my little tinkerer's lab here, you know, finally got this thing done. But boy, it took a lot of work. When I bought this thing, I just didn't have enough money to when I bought the Dillon, you know, I bought everything I needed, but I didn't have the extra money to buy the case feeder. And at the time I was searching for Dillon, I also ran across a lot of videos from guys who had built their own case feeders. So immediately I said, hey, you know what, I can probably do that. So I didn't buy the Dillon case feeder, looking forward to the time when I could actually do what you're seeing right now, build my own, and build one that works. And this one works. So I'm going to say bye, and we'll probably maybe get some more videos of this thing and take the insides apart so you can see what it looks like inside. But the construction videos that I've posted earlier are pretty much, you know, show all that. So bye. Hope you can build your own as well. If you got any questions, feel free to ask. Bye. Thank you.